Hey folks, welcome to another tutorial. Today I'm going to be showing you how to make the Edge-Lit Acrylic Project. So this project involves cutting a piece of acrylic to fit on the top of your project. It involves making a box out of 1/8" Baltic birch, and it involves making a 6 LED circuit, which is what this video is going to be about, is about making the circuit. So this is the finished product here. I'll show you a few more examples. I made this one with some fading RGB lights, so it changes colors, which is pretty fun. So let's get into it. We're going to be basically making this schematic here. It's really not that tough. It looks like a bunch of squiggly lines right now, but really it's just a battery, a switch, there's 3 resistors involved, and there's 6 LEDs involved. So all said and done, this is a very simple circuit, and it's a great one to learn a new program for making printed circuit boards called DipTrace. So start off by looking for DipTrace if it's not on your desktop. And we're going to start with a schematic capture because we want to make the schematic of this diagram first. And then from that schematic, we're going to be making our printed circuit board. No to this tutorial because I'm giving you the tutorial. All right. So welcome to DipTrace. This is the schematic version of DipTrace. So you can just make the printed circuit board just like without a schematic, but it's always good to make the schematic first because this is what sort of sets up the rules of your printed circuit board. You really don't want to be making a PCB without making the schematic first because then what's probably, there's no guarantees that it's actually going to work. So to begin with, you're probably not going to have this Highland Parts button here. You're probably just going to have our generic components on here. And DipTrace has, thousands of components. And we don't have all these components in the school here. So I have an easier list of components that we could use just for the components that we're using for this project. So step 1 is that we need to set up a library. So up here at the top, click on Library and go to Library Setup. And you're going to want to click Add to add a library. So then get into this new library group that you have here and click Add Library. And it's going to open up this little box here. We got to go looking for it. So the place to go find all this stuff, go into School Share, H drive. In the H drive, you'll see a Makerspace folder up near the top. In the Makerspace folder, you're going to find an Electronics folder. And you're going to find some DipTrace components in there. And these are the ones that we want. So just highlight everything and hit Open. And make sure it's on Components and Patterns. That's what we want. And hit OK. You probably don't want to call this New Library Group. Why don't we call this something that we understand, like, say, Highland Parts, or call it whatever you like. OK. And then up here in the Components bit, just make sure you got Highland Parts selected. And then suddenly the list shrinks way down to some very basic parts like batteries and resistors and capacitors and whatnot. Okay, so I'm going to flip back and forth to my schematic because this is what we're basing everything on. So I'm basically going to recreate this one in this video. And then I think I'll do the printed circuit board in the next video. So step number 1, it's always a good place to start with a battery. So just click on battery, bring it over here, click, there plunks a battery down. Right click to take the battery off, okay? Second up, may as well throw the switch in there right now because that's the next part that's right next to it. There's lots of different switches. So as an example, a SPDT means single pole double throw, which means if you had 2 circuits that you wanted the switch to connect to, this is what you would use. We're just going for a very simple NC or NO, which just means open or close. And what this is actually going to look like on the printed circuit board is just a couple of copper pads basically that we're going to solder our actual switch onto because we want the switch to be on the outside of the box for this project, not in the circuit board that we're making. So we need to make a couple of, wires that run to this switch. So I'm going to line this up straight with the other one and a little bit away so that I have to draw the line in between and right click that. Okay. Now, if you want to start drawing traces between things, it's this place wire button here. So when you need 2 parts to connect, you need to make sure that this part highlights. So you see how it's highlighted in red. Maybe I'll zoom in a little bit so you can see this a bit better. That's with control and the scroll wheel. So click on the pin there and click on pin number 2. There we go. So now these two are connected. Okay. Go back to the default mouse mode to be putting and moving the parts around. If you're on the trace, the wire placing button, you won't be able to pick up your parts. All that you're going to do is just keep drawing wires, which is probably not what you want. So make sure we're back here. So back to our schematic. Okay, we got our battery, we got our switch. Next up in the circuit, we need 3 resistors. So the value of resistor, it really doesn't matter because resistors are all the same size. We're going to be figuring out what value resistor we need later on. For now, all that we need to do is just get the spacing right in the circuit board. So we're using a 1/4 watt resistor. Pretty much all the resistors we have are 1/4 watt in the class here. And if you want it to look like mine, from this other picture here, you see how I've rotated these resistors? All you have to do is hit the space bar, and that rotates your parts around. So I'm just going to place 3 of them. 1, 2, 3. Doesn't really matter where you put them. And now I'm going to connect these 3. So all 3 of them are going to get connected to, let's do from positive through the switch. So I'm going to connect this part here to that part there. And I'm going to connect this one to that net. And I'm going to connect this one to that net. So you need to make sure that the highlighted color comes up. And you need to make sure that this little dot pops up. What that signifies is that these lines are actually connected to each other. When you see a couple of lines that crisscross each other without that dot, that means that it's actually a wire that runs past and not connects to this one net here. So just what a net means in this program is just basically everything that's connected from this pin to this one. And as you highlight any given part, it's going to show you where all of these places go. All right. And next up, we need an LED. So I don't think it's the RGB, no, because that one has a bunch of different pins on it. I want just a normal LED here. Okay. So there is a positive and negative side to the LED. This one's important. The resistors, it doesn't matter which way you go, left or right. But with the LED, you want those arrows and the direction of the arrow to be pointing towards the negative side. So in this instance, I want the LED to point down. And we actually need 6 of these. If I go back to my schematic for a second, there's 2 LEDs hooked up in series past the 1 resistor. And then that second LED gets connected to the ground of the battery. And there's 3 parallel little circuits within this one big circuit that have all of that. So I'm going to plonk 2 LEDs here, and 2 here, and 2 here. And then connect everything. And this is going to come around to ground. These connect. Again, make sure that it's blue. If I get it right here and the line is still yellow, you haven't connected them. You need to make sure everything gets connected. And 1 to there, there to there, and here we go. All right. So here's our schematic. At this stage, it would be extremely smart to save what you have. So go save as. Save this somewhere where it makes sense to you, like say your OneDrive or something like that. Maybe you have a folder for projects and stuff like this. So I'm just going to call this ELA for Edge-Lit Acrylic 6 schematic. And there we go. So I think I'll do the printed circuit board on the next video, but that's it for this one.